chapters total, chapter 16 to chapter 20. So the first chapter is about lines and angles. Okay, Nesma?
Okay.
So we have three important terms in geometry. The first one is line, and the second one is line segment, and the last one is ray. So do you know what is the difference between these three terms?
I think so. I mean, line is a line. So line is.
A line, what is the difference between line and line segment?
Um,
The line in mathematics which has two endpoints. Okay,
okay.
and that endpoints is represented by the arrows on both sides. So this is a line. So if this point is A and if this point is B, then the line AB is represented as this. Okay,
Yes.
and the second term we define now, that is line segment. The line segment has the two endpoints, but that endpoints not in the form of an arrow, but in the form of a dots, like that
Mm-hmm.
way, like that. So if there are that type of endpoints and the end of the line, then this is a line segment. And if this point is A and if this point is B, then the line segment is represented as this way. Okay, Nesma?
With the a dot circle.
Yes, the dot on both sides. When the arrow on both sides, then this shows the line. When the dot on both sides, then this shows a line segment.
Mm-hmm. Okay.
And the last one, we have a ray. So the definition of ray is that if there is a arrow at one point, if arrow at one point, then this is called a ray. For example, if I write in that way, then the arrow at only one side, if this side arrow, and this point is A and this point is B, then the ray is represented as AB. So this is a ray. Okay, Nesma?
Okay.
So ray, we have only one arrow at the one point, at the one side. Okay.
Mm-hmm. Yes.
Now the next thing we read today, that is segment addition postulate. So what is segment addition postulate? For example, we have a line segment in this way. Okay.
Mm-hmm.
And
Okay.
this point is P and this point is Q. This point is R. Okay.
Okay.
And
Okay.
and we have a point at that line segment. For example, if we have a point here, so that point is represented by Q. Okay, Nesma?
Okay.
Now the segment addition postulate, when we define it, it states that when there are 2 points on a line segment P and R, and the Q is the point is a third point at any place on that line segment, then we can make a formula. The formula is that PQ plus QR is equal to PR.
Oh.
It means that the distance of PQ plus the distance of QR, when we add them, it would be equal to distance PR.
Mm-hmm.
So this
Oh
is the
yeah.
formula. PQ plus QR equal to PR.
Formula.
Yes, this is the formula. This formula is known as segment addition postulate.
Mm,
Okay?
okay.
So note that formula.
Okay.
Have you noted it?
I'm still writing.
Okay.
Okay. I have noted it down.
Okay, so next thing we have a definition of a midpoint. So if I make a line segment, if I make a line segment, Nesma, in this way, for example, so this is the line segment, and this point is P, and this point is Q. Okay.
Okay.
And if I mark a midpoint, then midpoint, you know the definition is that a point which divides the line segment into two equal parts. That point is called midpoint, and it is represented by capital M. Okay, a point which divides the line segment into two equal parts. And you can see that PM is equal to MQ. Okay,
Mm-hmm.
PM is equal to MQ. So why it would happen? Because the M is the midpoint of a line segment PQ.
Mm-hmm. So I call it
Okay.
midpoint.
Yes. So M is the midpoint. So this is the midpoint definition of a midpoint. So if PQ is a line segment and M is the midpoint of PQ, then we can say that PM equal to MQ.
Oh, oh wait, PM equals to MQ. Okay, okay, yes.
Yes. Because the distance from that point to the midpoint would be equal to
Mm-hmm.
from midpoint to that point.
Mm-hmm.
Okay.
Okay.
And in other words, we can say that, Nesma, so if we have given a distance of PQ, so the PQ distance, for example, we have given that is 10 centimeter. Okay, Nesma?
Oh, okay.
And if we have to
Okay.
find PM, then what we do?
Um,
We have given this distance PQ, we have given this distance 10 centimeter, and we have to find the PM distance.
so the
Then
half
how?
of it.
Yes, then we divide 2. Then we divide 10
Mm-hmm.
by 2. We get the PM distance. So 5
It's two because
centimeters.
there's two parts.
Yes, because M is the midpoint.
Uh-huh.
So we divide the total distance by 2. So that converts the total distance into two equal parts. The 5 centimeter is the answer for PM, and for the MQ, it would remain same, the 5 centimeter.
Mm-hmm.
Okay.
Okay, but what if, for example, there's no midpoint?
If there is no midpoint, then we have applied the definition of segment addition postulate.
Mm.
For example,
Okay.
if there is a no midpoint here and there is a third point anywhere on that line, for example, if it lies on that, like this is the M, then we apply that formula segment addition postulate PM plus MQ equal to PQ.
Mm-hmm.
PM
Okay.
plus MQ equal to PQ. Okay.
Okay.
So now these are the three concepts. We solve the questions based on these concepts. So this is the question number one, Nesma.
Okay.
So we have given that P and R are 2 points that make a line segment, and Q is the midpoint of that line. Okay.
Okay.
And we have given that PQ is equal to x plus 3 and QR equal to 2x minus 1. So what is the length of a segment PR? We have to find the length of the segment PR. So how can
Oh,
how can we find it?
we can get x plus 3 plus 2 minus 1. And plus them both sides of
No, first of all, we will find the value of x. So if Q is the midpoint of PR, then which condition we can apply here? Can we say that the distance of PQ equal to QR?
Yeah,
Yes. So the PQ,
equal.
yes. So the PQ distance is equal to x plus 3 and QR distance is equal to 2x minus 1. Okay.
Mm-hmm.
Now combine the like terms.
Okay.
Nesma, combine the like terms. When we combine them, so the take x values on the one side and the constants on the other side. So 3 plus 1 is equal to 2x minus x. So that is equal x equal to 4.
Oh yeah. Oh.
But we
So then
need,
that's
but
the answer.
no, this is not a final answer because we need the length of PR.
Minus.
So
Yeah.
we apply here the segment addition postulate, and that states that PQ distance plus QR distance is equal to PR distance. Am I right?
Yes.
So what is the distance of PQ? What is the distance of PQ we have given in the question? X plus 3. X plus 3. The PQ distance is equal to X plus 3. Am I right, Nasma?
Yes.
So put the value of X4 in that PQ. So we have 7. So PQ distance equal to 7. Okay.
Okay.
And the QR distance equal to 2x minus 1. So if we substitute x equal to 4 into 2x minus 1, then what we get? 8 minus 1, that is also 7. So this is equal to 7 too. So when we add them 7 plus 7, what we get, Nasma?
14.
14. So this is the length of PR. So which option is the right one now?
Option B.
Yes, option D is the right one.
Oh.
So have you understood the question?
I'm trying to. No.
So here we apply both the formulas. First one, we apply the
How
formula
can
of
we?
line midpoint of a line segment, and then we apply the segment addition postulate.
Oh, we do two?
Yes, we apply both the formulas here.
Oh, okay.
Now the next question, we have question number 2. So this is the question. Can you solve that question, Nasma?
Yeah, sure.
Okay. So try to solve it because it is very easy.
There's like a formula required for it here.
Yes, yes, we apply the formulas of segment addition postulate.
Okay.
Nasma?
Um, so I did the formula of it, and then like the answer that came out for me was 6.333 equals 12.
Okay. Then what is your unknown value?
There are unknown.
Yes.
Yes. Oh my God, is it 1 over 3 PS?
No, you have to find here what is the length of PS. So this whole length. You have to find this whole length, Nasma.
Mm.
So first of all, what you do in that question, suppose that you have given the length of PR. Am I right? And you have given the length of QS. So suppose that the length of QR equal to X. So this length is equal to X, QR. Okay,
Yeah.
Nasma? So
Oh,
the length of
really?
QR equal to X. If we suppose that here, okay?
Okay.
So PQ. So if I have to find PQ, then PQ would be equal to PR minus QR. Am I right?
Hold on. What?
PQ is equal to PR. this total length PR, and when we subtract it QR from PR, we get PQ.
Oh,
Okay?
okay.
So we write here PQ. The PR is equal to 12. Okay? PR here equal to 12, Asma.
Okay.
And the QR we suppose here is X. So 12 minus X. Okay, Nesma?
Oh wait, this looks like a different formula.
We use that relationship QR equal to 1 by 3 PS. So we have to do, first of all, we have to find the PQ and we have to find the RS in order to apply that formula. Okay?
Oh, so then we can find the total.
Yes, we can find the total PS
Oh,
because here we have given the length of PR, we have given the length of QS, and we have supposed QR equal to X, but we haven't given the length PQ and RS. So we have to find them.
but um, but QR is given. Why does it become X?
QR equal to X, we suppose, just we suppose. So we substitute X in the place of QR at the end of the day.
Okay,
Okay.
okay.
So now PQ, we establish a equation PQ equal to PR minus QR, and then PQ equal to 12 minus X. And similarly, we write RS. RS equal
Oh,
to QS minus QR. Okay.
oh, okay.
QX we have given that is 16, and QR we suppose is X. So RS equal to 16 minus X. Okay, Nesma?
Mm-hmm.
And now we have given that QR equal to 1 by 3 PS. Am I right?
Uh-huh.
So here we can find the length of PS. So we take 3 on the other side. So 3 times QR. Okay.
What? Wait, we came from RS equals 16 minus X, and then after that it just became QR?
We find PQ, we find RS. And after
Mm-hmm.
finding that, we use that relationship QR equal to 1 by 3 PS. Here we find the PS value. We take the 3 on the other side. QR we suppose equal to X, and then PS become 3X.
Um,
Okay.
okay.
Now, if we use the segment addition postulate, then the whole line segment is equal to PS. Am I right, Nesma?
Mm-hmm.
And that would be equal to PS equal to PQ plus QR plus RS. Okay.
Okay.
And what is the length of PQ? We have find PQ.
12 minus X?
Yes, excellent. 12 minus X. And we add them. What is the length of QR? We have found
1 over 3.
no QR. We have suppose X equal to X. Am I right?
Oh, so it just always be X.
Yes, it would always be X. And what would be the value of RS? We have found, Nesma?
Uh, for RS.
16 minus X.
Mhm.
Okay. And what
Okay.
and what is the length of PS we have found here? 3x. You can see that.
3x.
Yes.
Mm-hmm.
Now solve that equation on your notebook and tell me what is the value of x. Solve that equation, Asma.
Okay.
You have to find the value of x first. What is the value of x you have found, Nesma?
X equals 28 divided by 4.
So x equal to 4. Am I right? So x equal to 7, sorry.
Which is 7.
Yes. So now what we have to found here, what we have to found in the question, what is the length
Which is
of
7.
PS? Am I right?
Yeah.
So PS is equal
Yes.
to
Then we
PS.
substitute.
Yes, we substitute. So PS equal to 3x. Am I right?
Yeah.
So 3 times 7.
Oh.
3 times
Really?
7. 3 times
Oh,
7.
21.
That is 21.
21.
So option C is the right
Yeah.
one.
Yeah, okay.
Okay, Nesma, understood. Now this
That's
question.
right.
Tell me the answer for this question, Nesma.
A 3.
Yes, question number 3. Definition of a ray. In case of ray, you have a one arrow at the one side. Okay.
Oh, it's called like
So yes,
diagonal.
so this is a ray. Okay.
Okay.
This is the ray towards the right, and this is the ray towards the left.
Oh, to the
So
opposite.
in the figure above, you have to find the opposite rays. So you have given the four different options here. So in the option A, you have given that ray AB. So tell me, can we say that AB is a ray?
Oh, yeah, yeah, yeah.
No, no. That's why AB is not a ray. AB is a line segment. You can see that we have the two dots.
What about the line, like in the arrow? There's no letter though.
Yes. So option A cannot be the answer because AB is not a ray. AB is a line segment.
Oh,
Now see the option B. Option B, we have ray CA. So C is that point and A is that point. And you can see that after A, we have an arrow. Okay.
okay.
So CA means that we have that line. That is C and that is A. So can CA is a ray? Can we say that?
How? But it's not near the arrow.
That's why you can see that we have an arrow at the end of the point. So A is the last point and C is that point. So when we measure from C to A, that make a ray. You can see that.
Oh,
Okay.
okay.
So CA is a ray. Now the second one is CD. Can we say that CD is a ray? So C is that
Yeah.
point and D is that point.
Mm, yeah, but are they equal in
And,
length? Is that okay? I
and you
mean,
can see that both are the opposite rays. One is towards the right and the second one is towards the left.
yeah.
So option B is the right one for this question.
Oh, the other
Okay.
ones are the same.
Yes.
Okay.
Now the last question we have, and that question is based on the previous concept, segment addition postulate, and you have to solve that question yourself. Nesma, tell me the answer.
Yeah, okay. And the formula is like normal.
Yes, apply the definition of a segment addition postulate. AB plus BC equal to AC.
Oh,
And here you have given a condition, firstly, Nesma.
uh, uh, what's the condition?
The condition is that the length of AB is equal to 2 by 3 times the length of BC.
Hmm.
Okay?
Okay. Okay.
So apply that condition and find the answer.
Okay. 25. That's the
Yes,
option B.
yes, 25 is the right answer.
Oh.
Okay. So Nesma, this is the first topic of our geometry
Yeah.
section, that is lines and angles. Okay.
Oh,
And
okay.
and now we do some questions from the past paper. And here we have a past paper, the module one of mathematics section. Okay.
Okay.
And that is the question number one. So in the question number one, you have given a word problem and you have to find the answer. So can you do that question? Question number one. Given a formula D equal to 30D. Okay.
Oh, yeah.
And you have given that T equal to 2 second. So put that 2 in that equation. So what you get?
So 3 times 2,
Yes,
right?
60 feet.
Because
So option C is the right one.
okay.
So this question is very easy. Just put the value of T in that formula and we have a answer. Now the question number two. So this is question on probability. So you have to find the probability of selecting a bead that has a defect.
Why is it defect?
Yes. So for a particular machine that produces beads, 29 out of every 100 beads it produces have a defect. It produces have a defect. So the total number of beads that a machine produces, that is 100, and the 29 out of 100 beads there is a defect. So what is the probability?
Oh, oh, okay. Well, out of 100,
Sorry?
the chance out of 100.
Yes, out of 100. So the total one we have given, that is 100.
Mm-hmm.
So if A is an event that shows the bead is a defective, then what would be the probability of A? The total we have 100, and out of 100 how many beads we have a defect? Nesma, tell me.
29.
29. So which option is the right one?
Option C.
Yes, option C is
Oh,
the right. Okay.
okay.
Now the question number three we have. In question number three, we have given a graph and we have to find the value of y-intercept, Nesma.
Oh,
Yes,
y-intercept is negative 8. Negative 0 and 8.
yes. So the which option is the right one?
Option D.
Yes, option D is the right one.
Okay.
So now the next question, we have a question number four. In question number four, we have to solve that expression.
Okay.
To solve that expression, tell me what is the answer from the given options.
Oh, we just kind of make it
Just
smaller,
just
simplify it.
just add, yes, just
Yeah.
simplify it and add the similar terms.
Okay. Is the correct answer option D?
Yes, option D is the right one.
Yay.
Yes.
Okay.
Question number 5. Can you tell me the answer? What is the question number 5? Value of
X.
x. What is the value of x?
1/5.
Sorry, in decimal. Tell me answer in the decimal.
0.2.
Yes, 0.2 is the right one. So the question number 7, Asma. The question number 7 is on percentage. Tell me the answer.
We do divide like 100 divided by 100.
No, we have given that there are total 300 seeds, and the 80% of the 300s are sprouted. So we have to percentage of the seeds which are sprouted. So it means that we have to
Oh,
take 80% of the 300. So 80 over 100 times 300.
mhm.
Tell me the answer.
Which 240.
Yes,
240.
yes, 240 is the right answer. Question number 8,
Okay.
Nesma. No, sorry, the question number 7.
7? Did you
Question
say?
number 8. Question number 8.
Okay. Oh, okay.
Zero is the right answer. Okay, Nasma, this is enough for today.
Yay.
So tomorrow again we have a class at 1 p.m. KSA.
Okay.
Okay.
Thank you.
We start the next topic of the geometry, and after that we'll solve some questions of the past paper.
Okay.
Okay, Nasma. Allah Hafiz.